So, hello everyone, good morning. Well, it's a time-bound presentation, so let's cut right to the chase. I'm Sundaresh, here's Imran. This is our super demo. And the core theme of our super demo is to help you understand how you can deliver powerful results without necessarily throwing a lot of power at your infrastructure. How do we do this? We do this through collaboration, not just as a team between SAS and Intel, but also in terms of software capabilities. And this way, for you customers, ultimately this translates into efficient, cost-effective, and intuitive AI solutions. In many ways, we are helped by the SAS Intel partnership in general. We take care of both above the line activities, things that talk about software capabilities, features, functionality that end users interact with, delivered by SAS applications oriented towards business use cases. But at the same time, we also pay attention to below the line capabilities, and those below the line capabilities relate to software that helps your hardware run better. Why? Because this affects speed and performance, and that in turn has a beneficial effect on costs. So Imran, why don't you take us further in terms of explaining the cost story?
Thank you. So running SAS VIA on the latest Intel Xeon 6 processors is actually beneficial to the customers in multiple different ways, right? So be it the most powerful processors that's available out there in the market for running SAS VIA, or running most processes right out of the box on a given system, Intel Xeon processors gives a distinct advantage for SAS users. And not just that, running SAS VIA on Intel Xeon, be it on-prem or on cloud, gives a major advantage in terms of cost analysis for the end customers who actually are price sensitive. Now, the latest Intel Xeon 6 processors are the best processors, CPUs for AI. And how have we achieved that? We achieve that by making sure that you have the most available performance cores on any processor that's available out there in the market. Combined with the bandwidth and the cache, the L3 cache, it makes ideal for running small models or even large scale models on Intel Xeon 6 CPUs. The distinctive accelerations available for Intel Xeon, which is advanced matrix extensions, ensures that the models, the deep learning models, be it bfloat 16 or integer 8, are running much more faster, much more efficient on the latest Intel Xeon 6 processors than any other competitor's product. And SAS using all these different deep learning models, be it computation models, natural language processing models, embedding models, or even LLMs, makes sure that you do not need to go beyond your on-prem deployment for surviving with your deep learning needs from an AI standpoint.
Thank you,
Now
Imran.
let's look at what SAS VIA does on these angles.
Wonderful, thank you, Imran. So we heard about the decisions that we make at an infrastructure level, but let's see how it translates to a use case on how we help enterprises adopt AI. The problem is AI adoption by enterprises is constrained by a variety of gaps. The first gap, the context gap. This relates to knowledge that's made available to the AI in order for it to make its decision. This knowledge is usually unstructured, voluminous in nature, and requires structuring, a whole lot of pre-processing before you go ahead with your solution. The second is the trust gap. And by trust, I'm not talking just about accuracy. It's also about consistency in results. It's about standard process to arrive at results. And it's about traceability so that you understand how an AI solution arrived at a result. The final gap is the action gap. And the action gap is the most fundamental ground level problem of all. It relates directly to how do we take actions to effectively implement our solutions. The reason the action gap is so important is it is core for us to actually get our solutions up and running, and that way we can satisfy all these forward-looking statements. But the problem is these are forward-looking statements right now, and there's every chance of us the community in general not being able to achieve these objectives. Why? Because implementing agentic solutions is hard. It requires a whole lot of answers and knowledge about the next slide. It requires a whole lot of knowledge about coding, about development, and this tends to be a little clunky. It requires an understanding of all the components that need to be made available to an agent, and you have to code for that complexity. Coding for the complexity, where you to approach it just like a standard software development story, tends to be very messy indeed. So how do we improve this? We make use of a new solution, Retrieval Agent Manager, which provides you agents, a framework for building agents in a quick manner, which are context aware and have access to the right tools to satisfy their needs. Let's take a look at the workflow of Retrieval Agent Manager. Now, when it comes to building an agent, the core steps that you have to take care of, you have to process documents, of course, because a lot of agents require data to work on, and everything starts with data. But just unstructured data, documents are not data alone. There is also solid, structured, numeric data which resides in traditional systems like databases and data storage mechanisms. How do you bring them into the fray? You need to organize those documents, pre-process those documents in order to make them suitable for retrieval, and that's how an agent knows it can actually identify the core pieces it needs among the ocean of information in order to do its work. And finally, once you develop agents, you have to be thoughtful. You have to make considered choices about which agents you have to develop to carry out certain activities. Let's look at an example. As I mentioned, data is the first step. And as part of RAM, we have various options to ingest data. These can come in from local files, files on your work system, files from a central repository, or even files that you programmatically retrieve from APIs and various web servers, repositories, document knowledge bases all across your enterprise. The next step deals with pre-processing these documents. Why? Data, it's both a blessing and a curse. Data can come from anywhere, we can handle it, that's great, that's a blessing. The curse is that data needs to be standardized in order to be retrieved in a consistent manner by agents. And for this purpose, we make use of configurations which run vectorization jobs, not just vectorization jobs, they also take into account the individual aspects you need to take into account when handling documents. Are there pictures in those documents? Are there tables? If there are tables, how do I extract them and load them into separate repositories for quicker access, yet maintaining the linkage? Now it's at this stage, when we carry out multiple configurations, you would notice a lot of interesting looking names out there. We have the flexibility of experimenting with multiple configurations and identifying the one that's best suited for us. One such experiment relates to the base, the environment under which you run this vectorization job. Because these are heavy documents, and that's no joke. You need to offer optimized environments in order for these documents to run in a time-efficient manner. Imran, I believe you got some stats which talk about that too.
Oh, definitely, thanks. And as you've seen with the different configurations that was used for extracting the text and processing it on to load into the Retrieval Agent Manager's database, what you've seen is that with embedding tasks where the text is going to be converted into a numeric vector precision type of sorts, when compared to the default run with Hugging Face inference, OpenWindow runtime server was 6.5 times faster than running that on a regular CPU conversation. So what it means is that it's going to be way much faster to process the humongous loads of documents that typically is going to be found in an enterprise setting. And not just that, for the end users to actually consume all those models that's available out there, be it the OCR models, or be it the embedding models, or be it even the LLMs that we talked about, we have a plethora of suite of applications that have been optimized to use Intel Xeon along with the AMX processing capabilities from the processor, right? So be it the common tools like Llama C++ or enterprise-ready inference serving like VLLM, SGLang, or even Red Hat OS that people tend to use at a predominant phase. That is all been optimized to run on Intel Xeon. So if you are looking for running these models in a sovereign setting, in an enterprise setting, in a most cost-effective settings for the regular task, the Intel Xeon is the best picture along with the SAS VIA for your end-to-end enterprise applications.
Thank you, Bram. And now let's see how it translates to a use case. Just a quick show of hands. How many of you are from the banking industry? Well, well, even if there are none of you from banking, chances are high that there are a lot of us who know of someone who runs into these thankless tasks, tasks for which nobody acknowledges them at the end of the day, yet that task is really important. One such task is that of a remediations manager at a bank. The idea is that remediations managers and officers take care of information about customers, ensuring that customer information is always sacrosanct, KYC, know your customer processes are adhered to, and information is always updated and current at any point in time. So you can see how an agent built with RAM, built on the data that we configured earlier, is able to efficiently retrieve data in order to answer a specific question. These questions can be of various types. These could be questions about process. What process should I follow in order to carry out a targeting criteria or to identify open tickets? It could be about data. Now imagine, can I actually vectorize all this data, solid data, customer observations in databases, secure databases, and expose them to agents? That's where design comes in really useful. You need to understand that what we do is we need to ensure we get proper metadata about the data in our solutions, vectorize the metadata so that they act as easy reference, standard operating procedures, manuals that you need to follow, data dictionaries, glossaries, and all of these are core in order for the agent to do its job. Now, as you can see, there are other things that we can do. We can even have the agent graph out things for us. We can have it carry out tasks like escalating a case, assigning a case to a relationship manager, carrying out deeper investigation in these cases. This requires not just a standard set of tasks, skills. It requires a variety of skills. And those skills happen to be across the board. This involves careful consideration of the components that support an agent and that help an agent answer a question. One such component is the basic large language model at the back end. Consider these two questions. The same question, simple question, how many tickets do I have? Similar answers. I should be afraid if I got different answers. But what differs among these two? What's different is that the first answer was fed by Claude code, and Claude, as we know, Claude Sonnet, runs on the cloud. It's served in this case from Amazon Bedrock. This involves a round trip that adds cost to every single interaction. 6 seconds may not seem like much, but 6 seconds into multiple interactions, multiple questions over a period of time, those numbers add up. Consider it with the second case, Llama 3 hosted locally. The reason it's hosted locally, the reason we are able to host it locally is because we got RAM set up to support local LLM hosting services using frameworks such as VLLM, OpenLlama, and others. And VLLM, if you recall, is part of the OpenVINO framework. So Imran, there are a whole lot of advantages to host LLMs locally, aren't they?
Totally. And what you can see right now from an emerging trend is the gap between closed source models and open source models is drastically reducing. What used to be like 2 years worth of difference in terms of performance from a closed source LLM to an open source LLM is hardly like 6 months right now. And with open source catching up, you are now seeing smaller, lighter, and much more efficient models running it on-prem, on edge, depending upon the use case that you would want to like. And specifically for agentic use cases, you have seen that people talk about token exhaustion, right? So agentic use cases use a lot of tokens, be it reasoning models, or be it the context that comes from the RAG pipeline or the agentic logs of sorts. In such scenarios, it is going to be far more efficient for people to run it on a CPU which has abundant RAM, enough cache, and also quite competent enough bandwidth to give a much more efficient output from an agentic AI standpoint, and is also applicable for this case that we are seeing from a RAG agentic manager. So if customer looking for a sovereign AI, for private AI, Xeon, Intel Xeon along with SAS VIA is the way to go.
Thank you, Imran. And as you can see, the key message is bigger is not necessarily better. Idea is, in addition to choices you make about technology components, there's a whole lot of design choices that you also ensure should ensure are part of the equation. We need to understand that it's better in some cases based on considerations like data sovereignty, all the reasons Imran mentioned, to host LLMs, make them small, compact. But at the same time, ensure that even when you design your data structure, the data that's available to your LLM, don't throw all data at it. Think about how you can construct metadata and have that metadata feed the LLM. Another use case of how smart design helps us. Questions like these, which actually carry out operations, they are best if they are not carried out by LLMs alone. LLMs need support structures, and those support structures basically are fed by what are known as model context protocol servers. I like to call them tools. That's all they are. There's a whole lot of jargon in the market. Model context protocol servers, the USB-C of agents. I don't know what a USB-C of agents is, but the key idea is that whenever there's a situation where you have to run data locally, you have to carry out an operation on your workstation, you have to retrieve data from a database, don't trust an LLM to orchestrate that job completely. An LLM basically wraps, it understands that it needs to call a tool, it relies on the tool, uses the data that comes from the tool, which is usually technical, jumbled up, use JSONs, but produces it in a consumable manner. And how it does it is fed through proper prompt engineering, as you can see here. You have to be careful about design aspects. That is, I cannot underscore that enough. You have to understand how exactly to instruct an LLM in order to think about a problem, understand it is aware of other tools that it can use, and call those tools at the right time. That brings us to the grand picture. The idea is LLMs and agents do not operate in isolation. They require support from the ecosystem. The ecosystem could reside externally on cloud providers or locally if the situation warrants it to be so. They require access to tools. Those tools require, in turn, access to much other powerful computes which are closer to data. For large enterprises, you do not want to create redundant systems. You don't want to create duplicate systems which mirror the logic. You basically want to create systems that can easily make use of existing programs, existing processes that reside in your analytical server that have already got the stamp of approval. All you need is a good way to connect to them. Perhaps that's where the USB-C analogy actually comes in useful. So to sum up, when you look at a MCP server, the idea is to make it as descriptive as possible, but also be parsimonious. Why? Anytime you call an LLM, all the information about the MCP server goes over as part of the package. If you want the LLM to be aware of context and aware of the tools, you have to feed it information. Now that's where a trade-off comes in. You have to be judicious about understand how exactly can we identify tools that are required for a particular context and shift the tool selection judiciously so that only certain tools go over and inform the LLM that it has access to it to make its choice and carry out its operations. So if we were to wrap up, the idea is that we can design LLMs very well and we can run them at scale. But when we run them at scale, there are problems of concurrency that come in. So Imran, if you could take us through that last stretch of concurrency.
Oh, thank you. So what you could see, the example that we just saw was a single user operating across a single repository of documents and using an LLM call to kind of automate the process, end-to-end process. But think about scale. Scale is where actually enterprises are going to be way much cost constrained. Is your enterprise going to be spending all of your marketing budgets just on token consumption? Or are they going to be just buying a few servers fitted with Intel Xeon 6 to go as much as 800 concurrent users for the LLM calls that you would want to run from a small language model perspective? The cost difference is going to be ideal, and customers can adopt Intel Xeon for cost-effective inference from an LLM standpoint. And moreover, we talked about context sizes. Context sizes up to 64,000 input tokens and 4,000 output tokens. You could have 30 concurrent users. And that is going to be a far more cost-efficient alternative for customers to run Agentic AI on Intel Xeon processors than to run on expensive consumer-grade hardware.
Wonderful, thank you, Imran. And finally, when we look at applications, the idea is that we have one consistent approach to a problem. We have a problem of how do we make optimum use of resources. We got a software solution to that. We got a software dealing with hardware solution to that. The key thing to note is that it applies across industries, because as long as you design things right, things will always flow seamlessly, irrespective of the industry, and there are a wide range of use cases anyways available in the market. So if you would like to know more, please do visit us at the respective booths. There's the Intel booth right behind the stator, and there's also the Agentic AI booth out here where we can share more demos and provide you more information. Thank you for your time. I believe we got a minute or so for questions. We are happy to take any questions. And thanks, Imran, for this great partnership.
Oh, thanks, Suresh. So, no questions. All right.
All right, thank you. So the Intel booth is here, Agentic AI booth. And in case you see us around, get in touch. Thanks.
Thanks all.